Myself, Dr. K. Viswanath Allamraju, Department of Mechanical Engineering, Institute of Aeronautical Engineering, Dundigal, Hyderabad. In this session, we are going to study what are the problems and going to solve problems on equilibrium equations or equilibrium conditions. Let us begin with a problem. Summation that we have to find out the reaction of the forces in this problem here. The problem is that a smooth circular cylinder of radius 1.5 meter is lying in a triangular groove, one side of which makes 15 degrees, this is the 15-degree angle, and the another side is the 40 degrees with the horizontal, that is DE. Find the reactions at the surfaces of contact if there is no coefficient of friction is 0 and the cylinder weight is 100 newtons. When cylinder weight is 100 newtons, and this cylinder is fitted in such a way that there are two contact surfaces here. One is at point B, another one is point here, A. So RA and RB, what are the reactions we have to find out? Those are the contact surfaces. When weight of the cylinder, that is 100 newtons, the weight of the cylinder is 100 newtons. If 100 newtons weight is there on a cylinder, is a groove, triangular groove, that means there will be contact between the groove and the cylinder. And what are the reactions at those contact points? This is RA and RB. So this surface is having inclination. These are the inclination making an angles. What are the angles here? That is 15 degree and it is 40 degree. So here the cylinder is in contact, is in touch with the surface. This is the contact surfaces. What are the reactions? Before going to solve those reaction forces, we have to know the equilibrium conditions. What are the equilibrium conditions are? There are two types of equilibrium. There are three types of equilibrium conditions. These conditions are highly useful in order to find out or to know or to maintain the stability of the body. When the body having a motion in horizontal, in x direction, so it should not be moved, it should be in static condition, stable in x direction. That means sigma x equal to 0 or sigma h equal to 0. Horizontal component, algebraic sum of all horizontal forces equal to 0. This algebraic sum of horizontal means this is horizontally in equilibrium. When the body will be in horizontal equilibrium when the forces are equal, the forces which is acting towards left direction and the forces are acting towards the sum of the forces towards left direction equal to the sum of the forces towards right direction. When it is equal, then the whole body will be in equilibrium horizontally. The next equation is that sigma y equal to 0. What is sigma y? That means algebraic sum of all vertical forces equal to 0. This algebraic sum of all vertical forces means the forces in vertical direction either upward or downward. The sum of the forces in vertical direction equal to the sum of the forces in downward direction, vertically downward direction. Then it will be in equilibrium. It will be stable and not to be movable in either upwards or downwards. It will be neutral. And the third one is sigma m equal to 0. Sigma m, that is moment equilibrium equation. Algebraic sum of all moments equal to 0. Clockwise, there are two types of moments. One is clockwise movement, another one is anti-clockwise movement. The clockwise moments equal sum of clockwise moments equal to the sum of anti-clockwise movements. Then the body will be momentarily in equilibrium. It doesn't move, it doesn't rotate. The effect of the movement is in rotation motion. That means doesn't rotate when it is in equilibrium. Then when these three conditions are satisfied, okay, leftward forces equal to rightward forces in horizontal direction, and another one is vertical upward force is equal to sum of vertical upward force is equal to sum of vertically downward forces, then it is in vertical equilibrium, vertically stable, it doesn't move it. And finally, if there is any rotary motion due to the force, that momentum, that clockwise moments equal to the sum of the force of anti-clockwise movements, then it will be in moment of equilibrium. So the body is in statically equilibrium means these three conditions should be satisfied. Then only the body will be in statically equilibrium. So under these why should we use these conditions? By using these conditions, we can find out the unbalanced force in horizontal. Suppose if it is whether horizontal force is equal or not, in horizontal equilibrium is there or not. Suppose the body is not in horizontal equilibrium, that means it is horizontally unbalanced. There will be some unbalanced horizontal force is acting. We can find out that unbalanced force by using this horizontal equilibrium equation. And there will be unbalanced in vertical motion. Unbalanced force can be calculated by using the vertical equilibrium. There is a motion pulling down, either pushing up. That unbalanced equilibrium equation unbalanced force can be calculated by using this vertical equilibrium condition. By using vertical equilibrium condition, we can find out the force which is being unbalanced. Because we are using that, it should be equal. So what is unbalanced? It comes out equal to 0. Wherever unbalanced is there in vertical force, that unbalanced force also comes. And third one is unbalanced couple can be calculated by using the algebraic sum of this couple, that is moment equilibrium equation. By using moment equilibrium equation, we can calculate the couple. What is the couple? Is where the unbalanced couple is. Such a way that by using that unbalanced quantity, we can balance momental equilibrium by using the couple value. Similarly, in vertical equilibrium, what is unbalanced vertical force is acting. By knowing or by using that value, we can make the body, or we can keep the body in vertical equilibrium condition. In a horizontal equilibrium condition, what is the force? Horizontal force is acting. That horizontal equilibrium condition. By using horizontal unbalanced force, and we can keep the body horizontal equilibrium. All right, with this introduction, or what is the use of these equilibrium conditions, we can calculate the unknown forces. Now here one more important is that by using these conditions, we are going to find out what are the reactions, contact forces. Now here in this figure, the 40 degrees acting on the plane GC, and CF there is 15 degrees inclination. So here the reaction is always normal to the contact surface. This RA, this RB is 90 degree normal to the contact surface. GC. Similarly, CF is the normal. CF is the 90 degree normal to the contact surface. The CF is normal 90 degree. Reaction always. Why it is the reaction? That is what here normal. Suppose the body is sitting here, circular surface. What is the free body diagram for this? The free body diagram is removing the supports and drawing the diagram with reaction and reaction forces. Then it is known as the free body diagram. Now after removing the support of this one, what is the free body? The contact, what is the reaction force acts? The reaction force acts normal. It is exactly normal to the contact. And what about action? Action is, this is the action, W weight. Weight is the acts vertically downwards. So, and the sum of the mass, the gravitational force passing through the center of gravity point, centroid point, which acts vertically downwards. Alright, W vertically. Why it is only we are considering? Because the orientation of the weight, the mass passing through the single point, that point is known as the centroid point or center of gravity point. Alright, through the center of gravity point, this weight acts vertically downwards. And the reaction force, which acts normal to this point of contact, which also passes through the centroidal point. These are the assumptions. Yes, the orientation passing through that center of point, center of gravity. So this is reaction force for this. R is the reaction. And if we consider another force, another surface here, So where is the point? Here, this is the point. How the reaction force acts. The reaction force acts normal to the surface. Normal to the surface. Exactly normal. Similarly, by using those concepts, so here the normal to the surface are acting. The next one, how to start doing? Now, these are the equations. By using here law of transmissibility of the forces, which is acting, even though, but the effect will be through this effect. Even though if it is affecting, the force is acting, that reaction passing through that RB. Now, the angle with which it is making, with this, there are two normal. By using the concept, the fundamentals of geometry principles, the angle with which is making here 40 degrees, DC and GC. If you draw a normal to the lines, that normal intersection also makes the same angle. Now, this is the line. Reaction force 100 newtons is acting downwards. This 100 newtons downward force is the weight is normal to plane DE, normal to the line DE. It is a normal line. And another line, this reaction RB is the normal to the plane GC. So this is the normal to the inclined plane. The angle, this RB reaction line of action and the line of action of the weight 100 newtons, both are normal to the inclination lines. RB is normal to the line GC, and this line of action of the weight is normal to the CE. Their intersection is same. That angle between intersecting is same as the angle of inclination of these two planes. That's why here it is 40 degree. Now similarly, this is making angle 15 degrees. This RA is a normal line. RA is the normal line to CF line. Line of action is CF plane. And this weight is normal to CE. Similar, the angle between line of action of RA and this 100 newtons is same as the inclination of 15 degrees. That is a 15 degrees. Now, after drawing the free body diagram, this is the line of inclination. Okay, here, if we replace here, this is RB line. This RB is making how much inclination? That is 40 degrees. And what about RA? This is RA. This RA is making angle of inclination is 15 degrees. Now what about this angle? This 40 degrees is same as again the concepts of mathematics. If we consider the 40 degrees line, this is the line of action of what? With inclination is 40. Same, this is also inclination. This is the same angle. That is RA. Yeah, RB. Now it is RA. What is the RA? This is 15 degrees. What about the line of action here to here? This is also 15 degrees. Now the weight is 100 newtons. Now, if you make it here, this is what we got it here. With inclination 15 degrees, this is RA and here it is RB. Yes, we got it now. This is 100 newtons. There are three forces are acting. This is RA, RB and weight 100 newtons. Now we need the other angles. This RA and RB between is how much angle? That is 55 degrees. What about this angle? So that we can apply Lami's theorem. We have to know the angles between 100 newtons and RB and the angle between RA and 100 newtons. So what is this angle is? We have to find out that those angles. Those angles are by using again basics of mathematics. Here it is this line of action is a 90 degree. What about this angle? 40 means the angle how much? 90 minus 40, that is 50. And here it is 90. And total the angle between the 90 plus 50, that is 140 degrees. Now what about this angle between RA and 100 newtons? That is 360 minus 140 plus 55. Then you will get it this angle. Or another manner is that this angle is how much? This is 90 degrees. And what about 90 minus 15? This is a 100, this is 15 degree. 90 minus 15 is a 75. Say 90 plus 75, this angle is how much? 165 degree. So now finally, here this angle is 140 degrees and here it is 165 degrees. We know by when the three forces are, this is a coplanar concurrent force system, three forces are acting at a point O. So how to find out RA and RB? By using Lami's theorem. We can apply Lami's theorem. By using Lami's theorem, we can find out RA and RB. How it comes? Again, RA by the angle between other two, sine of the angle between other two forces, that is sine of 140 degree. Next, RB by sine of the angle between other two reaction forces, that is RA and 100 Newton, that is sine of 165 degree. Next, 100 newtons by sine of the angle between other two forces, that is 55 degrees. 100 by sine of 55 degrees. So if we equate RA and 100, RA by sine of 150 and 100 by sine of 55, we can find out RA. And if we equate RB by sine of 165 equal to 100 by sine of 55, then we can find out RB value. RA and RB can be calculated. Alright, this is the methodology by which we can calculate RA and RB. Okay, now let us begin the solution now. Now solution is that, now you see RA by sine 50, RA by sine 40, wrong, here it is. RA by, yes, sine of 180 minus 40, then how much it becomes? Sine 40. RA by sine 140 or sine 180 minus theta, sine theta, that is also okay. Now RB by sine 180 minus 15, that is how much? Sine RB by sine 165. Sine 165 is nothing but what? Sine 180 minus 15, that is sine 15. Then 100 by sine 55. By equating RA by sine 40 degree equal to 100 by sine 55, then RA equal to 100 by sine 55 times sine 40, then the value comes as 780.5 newtons. That is the reaction at RA. RA is 78.5 newtons. What about RB? The RB is that by equating again RB by sine 15 equal to RB by sine 15 degree equal to 100 by sine 55 degrees. From that, RB equal to 100 by sine 55 times sine 15 degrees. Now, what is that RB? The RB is calculated as 31.6 newtons. RB is 31.6 newtons, RA is 78.5 newtons. Now, RA equal to 78.5 newtons, RA 78.5 newtons, 78.5 newtons, RA equal to 78.5 newtons. And what about RB? The RB is calculated at 31.6 newtons. 31.6 newtons. So, when the body is acting here, the 100 newtons body, the 100 newtons force is acting when it is in contact with 40 degrees and here it is in contact with 15 degrees. The 15 degrees inclination plane is experiencing the more reaction force, more load. Okay, in comparison to the contact surface at B. The contact surface at B is making the more angle, that is 40 degrees. So the 40 degrees is experiencing how much? 31.6 newtons. The 40 degrees is experiencing 31.6 newtons and RA is experiencing 78.5 newtons. That is what? 15 degrees. More load it is experiencing. Whereas 31.6, 40 degrees it is experiencing less weight, 31.6 newtons. Now the point is that what is the load? What is the weight of the cylinder? The weight of the cylinder is 100 newtons. This 100 newtons is shared by This 100 newtons weight is being shared by two planes, that is the GC plane and CF plane. The experiencing is that 31.6 newtons, and here it is 78.5 newtons. Thus, we can calculate by using Lami's theorem the weights of the cylinder or the reaction forces at contact surfaces. We applied Lami's theorem. Alright. Now, Lami's theorem is only applicable whenever there are three forces acting, or three forces acting, or three coplanar concurrent forces system. Okay. The next one is, if we consider the next problem, is very important problem. Here, two cylinders P and Q rest in a channel is shown in figure. The P and Q cylinder. The cylinder P has 100 millimeter diameter and weights is the 200 newtons, whereas the Q cylinder has 180 millimeters and the weight is 500 newtons. This is the 200 newtons and the weight is 500 newtons. If the bottom or the width of the box, the bottom of the width is 180 millimeters, okay, with one side is vertical and another side is having inclination of 60 degrees. This is the description. So determine the pressures or reactions at the 4 points of contact. How many contact points here? This is the point contact 1, point contact 2, 3, and the 4 point of contacts are there. At these 4 point of contacts, what are the reactions? R1, R2, R3 and R4. We have to calculate these reaction forces. Okay, how to calculate? Let us begin. So, the weights of the reaction forces, the weight of the Q acts downwards. The weight of the Q, that is WQ, acts downwards. What is the weight here? Weight is 200 newtons and the P acts downwards. Now, what are the reaction forces? This is a reaction which is normal to here. Reaction forces. And another reaction force. This is also another reaction, and here it is another reaction. Okay, these are the reaction. What more? This is the reaction, another reaction. These are the different reaction forces acts. Now, how to find out? This is the force diagram or free body diagram of which one? The free body diagram of the Q body we considered. The Q body we are considering the contact surfaces which is acting, alright, and it is R2. And what about horizontal force? This is R1. Yeah, we are considering, we are considering which cylinder? P cylinder we consider here. This is the P cylinder, and the cylinder R1, this is a contact surface 1 we considered here. This R1 is acting by using law of transmissibility of the forces. It can pass through the same along the line of action, that is R1. And this R2, it is acting upwards, R2. Okay. And the weight is acting downwards. Okay. Now here 200 newtons. So 200 newtons weight, R1 and R2 are unknowns, and we know the angle between them. The angle between, we know, apply the Lami's theorem. We can apply Lami's theorem in order to find out R1, R2. The angle between R1 and 200 newtons is 90 degrees. The angle between R2 and 200 newtons is the 90. So 90 plus 56.1, that is 146.11 degree. Then what about these forces? That is the angle, that is 360 minus 90 plus 56.1 degree. 390 plus 146.1 degree, then we can find out this angle. Then after finding out this angle, if we apply Lami's theorem, that is R1 by sine of 146.1 degree and 200 newtons by the angle between these two R1 and R2, that is the sine of 360 minus 90 plus 146.1 degree, that equal to R2 by sine of 90. By equating these two and equating these two, we can find out R1 and R2 can be calculated. After knowing an R1 and R2, thus we can know the R1 reaction at point 1 and here another point R2. Alright. So how to begin in that? The ED radius of the cylinder, we go through it, that is P equal to 100 by 2, that is 50 millimeter. And radius of the cylinder is 180 by 2, 90 millimeters. Now the point is that After finding out these angles, you equate it R1 and R2. That R1 is calculated as 134.2 newtons and R2 is 240.8 newtons. Okay. Apply Lami's theorem. The Lami's theorem is applied here. That is R1. How we have calculated this 56.1 degree? By using the concepts of 56.1 degree. 56.1 degree we need. How can we calculate this distance? This angle is required. We have to find out what is this force and what is this radius. Then we can know the angle of inclination with the horizontal. Sin of. So how to know? We know the radius. Okay. What is this total width is? The total width it is 180 millimeters. What is it? That is 180 millimeters. This is the, but we have to know what is this portion, so that we can know the angle of inclination. So 180 minus radius, okay, or 180 minus the radius of the P wheel, then we'll get this width, that is Q1. Okay, and the RP plus, this is RP and RQ, this is RP and RQ, RP and RQ, radius of small letters, RP and RQ. Then 180 minus the distance, the radius of the RP, we can know the distance of that equal to Q times Q1. Then what about angle? This angle of inclination, suppose theta. Then how it happens? Sin theta equal to, or cos theta equal to Q1 by RQ plus RP. What is the Q1? That is 118. That is 180 millimeter minus RP by RQ plus RP. Then theta comes. That theta becomes 56.1 degree. That's what calculation here it is shown. The calculation is shown here. 50 by 2, that is 90 minus. We go through those points. Then we get it this 56.1 degree. That is angle ABC. After that, apply Lami's theorem, that is R1 by sin 90 plus 56.1, R2 by sin 90, that is 200 by sin of 180 minus 56.1. Then R1 equal to, if we equate R1 by sin 90 plus 56.1 degree or sin of 146.1 degree. Then equate R1 comes. Then R2 comes. R2 equal to 200 by sin 56.1. You equate. Then R1 and R2 is calculated as 240.8 newtons and 134.2 newtons. Next, we calculated now reaction forces at a small cylinder. The small cylinder is that, now that is what that is the cylinder of Q. We use a P cylinder. Now consider Q cylinder. By using the Q cylinder, again you have to apply the concepts of, now Q cylinder we consider. How many forces are there here? There are 1, 2, 3. This is again R2 we know, no need to go for it. Now R3 and R4. This R3 acting at point contact 3 and R4 is acting. Now in order to apply Lami's theorem, we need the angles between them. So this is R3 is 30 degrees we know. This is the normal, but actually it is 60 degree. Alright, but with the horizontal, if it is 60, it is 60, then what about this horizontal? This is the 30 degree. That's why R3 is making 30 degrees. And R2 is 248.8 newtons. We know this R2 is passing down. R2, R3, R4. We know the R2 value and R3, R4 are our unknowns. So we can calculate this R3 and R4 by using which theorem? Lami's theorem. So by using Lami's theorem, R3 by sin 90 plus 56.1 equal to 248.8 by sin 60 degree. That is R4 minus 500 by sin of 180 plus 30 minus 56.1. So equate R3 by sin cos 56.1 equal to 240.8 by sin 60. Then R3 can be calculated. That R3 is 155 newtons. Next one, equate R4 and 248.8 by sin 60 equal to R4 minus 500 by sin 180 plus 30 minus 56.1. From that R4 can be calculated. This R4 equal to 622.3 newtons and R3 equal to 155 newtons. Thus, we can calculate R1, R2 and R3, R4. There are 4 contact points. Okay. In 4 contact points, we calculated here. This is the point of contact 1, R1, here 2, R2. And where is R3? This is the point contact 3, R3. And here contact point 4, R4. So thus we calculate by using the concepts of equilibrium equations, and actually we calculated by using what? Lami's theorem. So we can also apply equilibrium equations. The equilibrium equations are sigma h equal to 0, sigma v equal to 0. We can also apply, but I use it in this session, even though equilibrium conditions, but we use it here Lami's theorem, because only there are 3 coplanar concurrent forces are acting, 3 forces. If more than 3 forces are there, we have to go for what? We can't use Lami's theorem. That is the limitation for Lami's theorem. Now, the point is that here, again, the summary in this completely, we use Lami's theorem, but also we can apply equilibrium conditions. The equilibrium conditions, these are also Lami's theorem also useful to find out unknowns when 3 coplanar forces are acting on a body. Now the references we followed here, there are the various references we followed for solving these problems. Let me summarize what are the things which we calculated here. In this session we have studied how to find out the reaction forces by using Lami's theorem, and also this Lami's theorem is one of the part of the equilibrium conditions. I mean Lami's theorem is to find out unknown forces. So, but equilibrium conditions also can be applicable. How to find out the equilibrium conditions? Yes, let us, we can work out here how it is. Consider any equation. Yes, I'm going to consider here equilibrium condition. We can apply here sigma fx equal to 0, make it R2, that is R2 cos 56.1 degree, that is R2 sin 56.1 degree. Now sigma h equal to 0, apply equilibrium condition. What is it? Sigma h equal to 0, that is R2 cos 56.1 degree minus R1 equal to 0. Next is sigma v equal to 0. What is sigma v? R2 sin 56.1 minus 200 equal to 0. From that what will come? R2 comes. Substitute the value of R2 here, then R1 can be calculated. These are the equilibrium conditions. After knowing R1, R2, we calculate it directly here. Very simple. No need to go for Lami's theorem also. Now next one is that, suppose here again we go for the next equation. In this case, yes, equate again. This is R3 cos 30 degrees and here R3 sin 30. And what are one more here? Here R2 sin 56.1 degree. We know the R2 here, 56.1. And horizontal is R2 cos 56.1. Apply sigma fh equal to 0. What is sigma fh equal to 0? R3 cos 30 minus R2 cos 56.1 equal to 0. We know R2 value from equation before we calculate, that is 240.8 newtons. R3 can be calculated. What is sigma v equal to 0? What is sigma v? That is R3 sin 30 minus R2 sin 56.1 plus R4 minus 500. We know R2, we know R3. Substitute here, then R4 can be calculated. Thus, we can use equilibrium conditions directly, but here we session mentioned Lami's theorem. So, these are the applications of equilibrium conditions in order to find out the reactions where the cylinder is in contact with the surfaces, that means at contact points. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.